Right now, you are slipping into the outer darkness of the solar system, farther than 5 billion kilometers from the Sun. And in this frigid frontier waits an object that refused to obey the rules. A world smaller than our moon, yet powerful enough to break astronomers' expectations and remind us that the universe never asks for permission. For decades, Pluto was the 9th planet dismissed as a leftover. But when humanity finally sent a spacecraft to meet it, the truth hit like a comet. We didn't see a frozen corpse. We saw a living world. We saw nitrogen glaciers, water ice mountains taller than the Alps, and beneath it all, something warm, something hidden, something scientists still discuss today. So why did they tell you Pluto was nothing more than a leftover? What else is hiding frozen beneath its plains? If you enjoy journeys that change how you see the universe, please like, subscribe, and tell us where in the world you are listening from. Join me now as we step into the dark. Let's begin. They told you Pluto was nothing, a cosmic afterthought, a frozen pebble at the edge of the solar system, too small to matter, too distant to care about, too abnormal to count as a real planet. In classrooms and textbooks, Pluto appeared as a faint dot, an asterisk, a misprint from the early days of astronomy. If you grew up hearing about it, you probably heard it spoken with a shrug, the same way someone might mention a forgotten town beyond the horizon. Yes, Pluto exists. Technically. That was the lie. And like all great misconceptions, it began with simplicity. The solar system had 8 planets, neat and tidy. Everything orbited the Sun in elegant, flat rings. Mercury hugged close. Neptune lurked at the outermost edge. The narrative was perfect, self-contained, orderly, easy for humans to memorize. Pluto ruined that order. Its orbit tilted, its year stretched across 2.5 centuries. It crossed Neptune's path. It refused to behave. Imagine holding a snow globe. The scene inside is tiny, perfectly arranged. That was our solar system. Planets lined up like marbles, moons arranged neatly, the Sun at the center. But then someone whispered, "What if the glass is scratched? What if the world isn't molded the way you think?" Pluto was that scratch, small, but undeniable. The easiest way to deal with a scratch is not to clean the glass. It is to pretend the scratch is insignificant. Astronomers called Pluto a leftover, a relic, a frozen remainder from the early solar system. They described it as a failed planet, a body that formed too far from the Sun, too slowly, too cold to heat or reshape itself. If the solar system were a city, Pluto was the abandoned outpost at the edge of town where nobody lived anymore. And yet, something strange happened. Its orbit, chaotic and elegant, locked perfectly in a 3-to-2 rhythm, with Neptune never colliding, always dancing. Its moon Charon was so massive that the two bodies orbit a point in space beyond Pluto itself, making them a binary world. And its surface barely seen through Earth-based telescopes hinted at patterns, brightness variations, textures. Questions began to form like frost on glass. If Pluto was dead, why did it look so alive? Instead of rewriting the story, we minimized the character. The solar system model was too precious, too symmetrical to break. And so, for decades, the simplest answer echoed: Pluto was a mistake. A misclassification, a planet only because we didn't know any better. But simplicity is comforting, not accurate. And Pluto has always had more to say. Before Pluto had a name, it was a rumor, a mathematical ghost, a missing piece in the solar system that astronomers were convinced had to exist. They called it Planet X not because they knew what it was, but because they didn't. It was an algebraic placeholder, a mystery waiting to be solved. If Neptune wobbled when it orbited the Sun, then something unseen was tugging on it. And if something unseen existed, humanity would go looking for it. At the end of the 19th century, Percival Lowell was already obsessed. A wealthy astronomer with telescopes larger than most observatories owned, he believed the universe hid secrets from those unwilling to stare long enough. Lowell spent his last years poring over star charts, hour after hour, night after night, hunting for microscopic discrepancies in Neptune's motion. He died before he found an answer, but not before leaving behind a prophecy. Somewhere beyond the 8th planet was a 9th. Most astronomers dismissed him. They called the idea eccentric, wishful. His calculations, they said, were flawed. The solar system was done, complete, wrapped in a ribbon of certainty. But at Lowell Observatory, one quiet, methodical man inherited the task of proving whether Lowell was delusional or visionary. Clyde Tombaugh was not a senior researcher. He wasn't even a university graduate. He was a farm boy from Kansas with a talent for building telescopes from parts of farm machinery. His reward was the most tedious job in astronomy: scanning photographic plates, two nearly identical star fields, taken nights apart, and checking for anything that shifted. A planet would move, a star would not. There was no glamour in the work. No digital overlays, no computers, just two metal frames, a blinking table of light, and Clyde's eyes staring into eternity for hours at a time. Every day he inspected thousands of stars, searching for a dot that didn't belong. Weeks passed, nothing. Months passed, still nothing. He was 23 years old, and already the world had decided Lowell's Planet X was a myth. Then, on February 18th, 1930, something moved. A tiny spot of light shifted against the background stars, a barely perceptible migration. Most people would have blinked and missed it. Clyde did not. He checked again and again, confirming the drift. That little point of light became Pluto. It was not a comet, not a trick of the equipment, not a cosmic smudge. It was real. When the announcement went out, humanity reacted with surprise and relief. Planet X existed. The solar system was larger than we thought. Pluto was embraced, celebrated, given a name from a child's suggestion. For a moment, humanity allowed itself to be humbled. But here is the twist they don't tell you. We never found Planet X. We found something stranger, something too small to explain Neptune's wobble, something that broke the model instead of completing it. Pluto was not the missing piece. It was a doorway. When Pluto was announced to the world in 1930, humanity didn't hesitate. There was no debate, no committee, no public vote. The newspapers simply printed the headline, "A new planet has been found." Not because of what it was, but because of what we wanted. In those days, astronomy was a frontier of pride. Telescopes were national trophies. Discoveries were political banners, symbols of progress and prestige. Europe had Uranus and Neptune. The great observatories in Britain and France had mapped clusters and nebulae. The discoveries were trophies on their walls. The United States had nothing until Pluto drifted into Clyde Tombaugh's blinking comparator like a grain of sand caught in the wind. Overnight, the smallest, faintest world became a cosmic flag planted in the void, and nobody wanted to inspect the ground beneath it. The truth was inconvenient. Pluto was tiny, far smaller than anyone expected. Observations suggested it might be as big as Earth, maybe a sibling to Neptune. But every new measurement shrank it further. Mars-sized, then Mercury-sized, then smaller than Earth's moon. Its orbit was wrong. Its brightness was strange. Nothing about it fit the neat categories astronomers preferred. But in that moment, accuracy took a back seat to triumph. The discovery itself became the headline, long before the details truly caught up. The textbooks grew bold. They listed 9 planets, 9 names to memorize, 9 bodies orbiting obediently around the Sunday. Diagrams became simple, symmetrical lines. 8 massive giants and 1 lonely runt at the edge, but still a member of the club. Science loves clean stories. The story of Pluto became a fairy tale. Discovered, named, placed in the order of planets, taught to children before anyone understood what it actually was. And there was another problem, one few dared to acknowledge. We had no idea what the outer solar system even looked like. Astronomers assumed the cosmos thinned like mist the farther you traveled from the Sunday. Dust, comets, maybe a lonely ice ball here and there. Pluto was the outpost, the last defender of a fading empire, a singular anomaly at the end of the solar system's map. The world beyond Neptune was a blank space labeled probably nothing. So Pluto survived not on merit but on ignorance. It was easier to crown a mystery than to challenge the narrative, easier to expand the family than to redesign the house. And so tiny Pluto, dark, icy, and misunderstood, was elevated to planetary status simply because people wanted it to be true. But misconceptions have consequences. For decades, astronomers kept running into contradictions. Planets aren't supposed to cross another planet's orbit. They aren't supposed to pair with massive moons like binary systems. They aren't supposed to be the size of dwarf satellites. Each fact chipped away at the illusion. Each new observation was a knock on the door of a house built on sand. Pluto wasn't a fraud. Our story about it was. We had declared it a planet before we understood what it was, and long before we understood what lay beside it. For 76 years, Pluto lived alone in the cold, an oddity, a curiosity, a tiny 9th planet wandering the outskirts of our solar system. It survived countless textbook editions, classrooms, and childhood posters, not because it made sense, but because no one dared to challenge tradition. Kids memorized it, teachers taught it, astronomers tolerated it. Pluto was the strange relative everyone pretended belonged at the dinner table, until someone walked in who looked just like it. In 2003, an object was spotted beyond Pluto. Faint, slow, dim, but unmistakable. It wasn't a comet. It wasn't debris. It was a world, larger than Pluto, brighter, heavier, a planet by every old definition, yet belonging to a realm nobody had ever explored. They named it Eris, after the Greek goddess of discord, as if the universe itself understood the trouble it was about to cause. Suddenly, Pluto was not unique. It was not the mysterious rebel at the edge of everything. It was merely the first of many worlds hiding in the Kuiper Belt, a population astronomers had chosen to ignore. The solar system was not 8 planets and a mistake. It was a crowded frontier of planetary-sized bodies, each waiting in silence for our telescopes to mature. This revelation posed a problem, a political problem, a psychological problem, not a scientific one. Because if Eris was a planet, so was Pluto. And if Pluto was a planet, so were dozens of others. Makemake, Haumea, Quaoar, Sedna, Orcus, a tidal wave of icy bodies gravitationally sculpted by ancient migrations. Imagine the chaos. Imagine textbooks listing 20 planets, 30, 50. Imagine teachers explaining binary planetary systems, partial resonance traps, dwarf planet genealogies, a universe that was not tidy. So instead of expanding the definition of planet, the astronomical community did something far simpler. They shrank it. They built a smaller box, then locked Pluto and its siblings outside. The demotion wasn't just a clarification. It also worked as a strategy, whether deliberate or not, to preserve a familiar, simple picture of the solar system. A planet, they said, must do three things. Firstly, they must orbit the Sunday. Secondly, be rounded by its own gravity. And thirdly, clear its neighborhood of other bodies. The first two Pluto accomplishes easily. It orbits the Sunday. It is spherical, a world with mountains and weather and atmospheric chemistry. But the third requirement was a noose. Pluto lives in a region where thousands of objects share space. No single world could ever clear it. And so the definition ended up being one that, almost inevitably, pushed Pluto outside the planetary club. The moment the vote passed, Pluto's planetary status was erased, not because its nature changed, but because admitting the truth would break the model. The solar system was not a quiet arrangement of 8 worlds. It was a sprawling archipelago of planets, planet fragments, and frozen survivors scattered across billions of kilometers. If Pluto had remained a planet, every other Pluto-sized world would demand a seat beside it. The solar system would become complicated, wild, alive. Instead, the label changed. Not the universe. And in that moment, Pluto stopped being the 9th planet and became the first victim of our fear of the unknown. When people picture a planet and its moon, they imagine a simple hierarchy. The planet is the ruler, the moon is the follower. Earth tugs on the moon, and the moon obediently orbits it. Jupiter commands dozens of satellites like a king surrounded by loyal servants. This structure is comforting, predictable, easy to teach. But Pluto ignores that order. It does something forbidden, something no other planet does. It shares its throne. Charon, Pluto's largest moon, is not a pebble drifting around a giant. It is nearly half Pluto's size. If Earth had a moon equivalent in proportion, it would be the size of Mars. The result is a gravitational relationship so unusual that moon is barely accurate. Pluto and Charon orbit each other, not in a distant circle like a planet and its satellite, but around a point suspended in space between them, a barycenter. Let that image settle in. 2 worlds, locked together like partners in an ancient dance, circling a center of mass that exists not within one body, but in the void between them. Their balance is almost perfect. You can picture it as a cosmic seesaw where neither side touches the ground. They face each other eternally, tidally locked, showing one hemisphere to their partner forever. No sunrise from the other world, no shifting of faces, just 2 worlds staring into each other's frozen silence. In planetary science, that arrangement is not merely unusual, it is taboo. Because it breaks the unspoken narrative. Planets dominate. Moons submit. A binary world is a threat to our categories. It demands a new vocabulary. It forces us to admit that celestial bodies can be equals. Charon's gravity does more than tug. It sculpts Pluto. It stretches tides in the ice, influences the orientation of surface features, and stabilizes the system in ways no single planet-moon relationship ever could. Together, Pluto and Charon form a miniature solar system with their smaller moons, Styx, Nix, Kerberos, Hydra, circling like debris around a double star. Their shared orbit is slow and deliberate, 1 revolution every 6.39 Earth days. But this isn't the gentle motion of Earth and the Moon. This is choreography. The 2 bodies rotate such that each shows the same face to the other forever, like dancers who never break eye contact. There is no front or back, no hiding. They have lived like this for billions of years. When New Horizons approached Pluto, scientists expected a moon orbiting a master. Instead, they found a partnership equilibrium, balance, shared momentum. And this is why Pluto unsettled astronomers more than its size or its orbit ever could. Because if Pluto and Charon form a binary world, They are not simply planet plus moon. They are a new category. Two worlds of almost equal authority. A forbidden category. Had Pluto remained a planet, Charon would have demanded its own title. Not a moon, but a co-planet. A planetary pair orbiting the Sun together. And if such a system exists once, it may exist dozens of times in the Kuiper Belt, an entire population of binary worlds hiding in the darkness, rewriting everything we thought planet meant. We stripped Pluto's title not because it failed our definition, but because our definition failed Pluto. Most worlds wear their past like scars, craters, valleys, frozen basins that tell a story of impacts long forgotten. Pluto carries its past differently. It wears it like a shattered crown. Beyond Charon, 4 smaller moons orbit in uneasy silence: Styx, Nix, Kerberos, and Hydra. Their names sound mythic, but their behavior is something stranger, almost violent. Each of them spins as though trapped in a memory of catastrophe, rotating unpredictably, refusing to align with Pluto or Charon, as if still recovering from the event that created them. The prevailing theory is deceptively calm. Once, billions of years ago, something massive collided with Pluto. A wandering body, maybe the size of Charon, struck it at a shallow angle. The surface split. Fragments flew into orbit, caught by gravity before they could drift away. Those fragments coalesced, cooling into irregular shapes, not spheres, not worlds shaped by gravity and time. Jagged shards of ice rock, stitched together like broken pottery. From that debris field, Charon formed the largest, most stable survivor. The others remained restless, like children that never learned to sleep. When spacecraft observations finally revealed these moons up close, scientists were stunned. They expected something simple: small bodies tidally locked like every minor moon around every major planet. But Pluto is not Jupiter, and Charon is not a master. Instead of orderly rotation, the moons tumble. They spin like coins flicked across a tabletop, unpredictably, never the same twice. Their days do not match their orbits. They do not present the same face to Pluto. They wobble, lurch, and veer as if the laws of motion have been smeared. Nix rotates so fast it completes multiple spins for every orbit. Hydra tumbles like a baton tossed by an impatient juggler. Kerberos, dark and uncertain, flips without warning. Styx is the smallest, barely a pebble in cosmic proportions. Yet its rotation behaves as though it is still negotiating its identity. Astronomers measured their chaos, ran simulations, and found the same unsettling truth. There is no stable orientation for them to rest in. The gravitational pull of 2 near-equal parent bodies, Pluto and Charon, shreds balance. There is no down, no reliable axis to align with. They exist in perpetual confusion. Imagine living in a world where your sky changes direction every hour, where the ground seems to tilt in ways no compass could explain. That is the moon's existence. They are not simply orbiting, they are surviving. Their behavior is the fossil imprint of a trauma so ancient that time could not erase it. And here is what makes them frightening, almost poetic. They don't calm down. Even after billions of years, the moons remain restless. No friction, no tides, no gradual slowing has tamed them. Their chaos is preserved perfectly like an echo trapped in crystal. Pluto and Charon may be partners, but their smaller moons are witnesses. They watched the collision that forged the binary world. They are the debris caught in its aftermath, doomed to orbit the scene of the crime forever. Their jagged surfaces and erratic spins whisper the same truth. Pluto was not shaped gently. It was shattered. When New Horizons approached Pluto in 2015, NASA expected a corpse, a fossil world, frozen and unchanging, its surface scarred by impacts and silence. They imagined ancient craters and a static crust of methane ice, the typical fate of small, airless bodies at the solar system's edge. But what they found was a message carved into the planet itself, a pale, unmistakable heart stretched across the surface, gleaming against the darkness. And worst of all, it was fresh. That heart was not random coloring. It was not a trick of the camera. It was active geology, a living surface. When the first images arrived, engineers fell silent. Scientists stared. The data contradicted everything they had been told to expect. A world with almost no sunlight should be inert. A body smaller than the moon should not move, breathe, or reshape itself. Yet Pluto stood there like a challenge, offering a landscape so dynamic it made Mars look ancient. At the center of that heart lies Sputnik Planitia, a basin of nitrogen ice kilometers deep in ocean, except its water is air frozen solid. The ice is so thick and heavy that it presses downward, deforming Pluto's crust, pulling mass toward it, influencing the orientation of the entire planet. This wasn't the battered shell of a failed world. It was an active engine. The surface patterns alone revealed the truth. Not pits or fractures like a dead rock. Not simple polygons or wind streaks, but vast cellular shapes, hexagons and ovals, frozen convection cells, the size of entire countries. Imagine boiling water slowed to geological time. Warm nitrogen from below rises. Cold nitrogen near the surface sinks. Each movement takes centuries. Each frozen plate circulates like tectonics without stone. On Pluto, even the ice flows. New Horizons captured these flows in exquisite detail. Ridges at the edges of cells where nitrogen accumulates, depressions where it sinks, smooth plains where the crust resurfaces. No impact crater can survive long there. They melt into this frozen sea, erased slowly but relentlessly. Just as wind smooths dunes on Earth, Pluto's nitrogen glacial tides paved over its wounds. NASA's internal teams debated the images in real time. Many expected to retire seeing Pluto as a relic. Instead, they were confronted with a contradiction so profound that the mission's own documentation reads almost emotional. Some asked if they had misinterpreted the data stream. Others questioned whether the heart was an illusion, an artifact of compression, a glitch in transmission. But there was no glitch. Every model confirmed the same impossible conclusion: Pluto is geologically alive. It forced the scientific community into a confession. If a tiny world at the edge of sunlight could harbor flowing glaciers and resurfacing plains, then size no longer governed geological destiny. A body did not have to be massive to possess internal heat. It did not need proximity to the sun to evolve. Pluto shattered the hierarchy. Tombaugh Regio was more than a landmark. It was a revelation carved in nitrogen, a reminder that we had expected a corpse and instead found a beating heart. On Earth, glaciers are born from snow layers upon layers of frozen water, compressed under gravity until they flow, slow and steady, carving valleys over millennia. We understand them intuitively. They are ancient rivers frozen into time. But Pluto's glaciers are something else. They are not built from snow or water. They are sculpted from the very air we breathe. Nitrogen, the gas that fills our atmosphere, settles there in sheets kilometers thick, compressed so brutally by the cold that it behaves like molten rock. This is the paradox at the heart of Pluto. The substance that makes our skies blue becomes its oceans. In Sputnik Planitia, the western lobe of Tombaugh Regio, nitrogen ice gathers like a living sea. It does not sit still. It does not rest like a frozen lake on a windless night. It churns. It shifts. It slides into basins and pools into valleys like syrup. When sunlight filters through Pluto's thin atmosphere, even the faintest warmth is enough to coax nitrogen into sublimation. Gas becomes liquid, then becomes solid again, cycling not over days or weeks but over centuries. Imagine an ocean that freezes into crystal, melts again, and flows beneath its own weight, all without a drop of water. The patterns on Sputnik Planitia tell the story. Each segment of its surface is a polygon, a cell of frozen nitrogen spanning tens of kilometers. They resemble cracked paint on an ancient canvas, except these cracks breathe. The centers rise and the edges sink as material circulates, upward from the depths, outward toward the periphery. It is convection, the same physical process that churns magma beneath Earth's crust or bubbles soup on a stove. Only here, the pot is a dwarf planet and the liquid is a gas turned to stone. When New Horizons transmitted its close-up images, scientists scrambled to explain them. If Pluto were inert, if it truly were the dead rock the textbooks promised, those cells would be impossible. They require heat. They require movement. They require energy. Something within Pluto that refuses to die. Beneath Sputnik Planitia, nitrogen sinks, thickens, and moves like ice water trapped beneath a frozen surface, warmer pockets rising like ghosts from the underworld. The plains do not simply exist, they evolve. The ice sheets are thick enough to crush anything that lands upon them. A meteor impact does not leave a crater, it disappears. The glacier erases it, smoothing the wound until nothing remains. Pluto rewrites its own surface like an author who refuses to let a page stay stained. And here is the part that unsettles researchers most. No one knows how Pluto sustains this motion. There is no sun to warm it, no tidal giant like Jupiter to knead its core, some whisper of radioactive decay deep within the crust. Others argue for an insulating ocean of water beneath the ice, a heat engine hidden beneath miles of nitrogen sheet, pumping energy upward, slowly, relentlessly. On Pluto, air becomes ocean. To call it bizarre is to undersell the truth. Sputnik Planitia is not just a glacier. It is the beating circulatory system of a world we thought was dead, a living sea of frozen breath. On Pluto, the most familiar substance in the universe becomes unrecognizable. Water our oceans, our storms, our lifeblood does not flow, shimmer, or erode the land. It towers. It withstands. In the brutal cold of Pluto's environment, where temperatures plunge to 230 degrees Celsius, water freezes into something stronger than granite. It does not behave like ice on Earth, fragile and ephemeral. It becomes a mineral, a structural material, the foundation from which mountains rise. And so, when New Horizons swept past Pluto, the spacecraft didn't see gentle snowcaps or rolling frost. It saw jagged peaks piercing the sky, their ridges sharp and defiant, like the ruins of a shattered continent. Do not imagine these mountains as the stiff, lifeless formations of a dead moon. They are young, shockingly young. Norgay Montes and Hilary Montes, named in honor of Everest's conquerors, stand 3 to 4 kilometers tall, Everest-sized mountains on a world smaller than our moon. Their shapes are too steep, too crisp, too unraveled by time to be ancient relics. They should have sagged, they should have crumbled. Over billions of years, soft ices like nitrogen and methane would collapse under their own weight. The mountains should be dunes, not cathedrals. But water ice is different. It is Pluto's rock. Under pressures experienced at these extreme temperatures, water becomes a rigid scaffold. It can support giants. Where nitrogen flows like lava and methane drifts like snow, water is the bedrock that refuses to yield. It is the crust upon which Pluto writes its story. When the first images arrived, geologists were forced to confront an unsettling possibility. Pluto is not a small version of Earth, nor a sphere of cryogenic frost. It is an alien planet operating under foreign rules. Its geology is not a warped imitation of terrestrial processes. It is its own category. Picture this. Pluto's surface layers are made of volatile ices, compounds that condense and evaporate like breath in winter air. These form the glaciers and plains of Sputnik Planitia, but beneath them lies a vast, rigid framework of frozen water. Impacts crack it, convection lifts it, and ancient collisions sculpt it. The water ice rises in blocks that thrust upward like rebellious tectonic plates, only to be locked forever in their frozen form. The absence of heat, paradoxically, preserves these monuments. On Earth, wind and rain erode peaks, tectonics tears continents, water eats mountains grain by grain. On Pluto, there is no weather to sand the edges, no liquid to hollow them, no atmosphere thick enough to break them down, only the slow passage of cosmic time, leaving the mountains sharp, unsoftened, unapologetic. New horizons revealed cliffs with shadows that stretched for kilometers, valleys carved not by rivers, but by the slow migration of nitrogen glaciers slithering around the base of ice rock peaks. We saw terrain that looked volcanic, yet birthed not from fire, but from the cryogenic contraction of frozen oceans. Scientists began to whisper it quietly at first. Pluto is not a remnant. It is an architect, a world that shapes itself through forces we barely understand, where the familiar becomes alien and the frozen becomes powerful. On Pluto, water does not melt, it endures, and in its endurance, it builds mountains, monuments, to a universe we thought we understood. There is a belief we carry unconsciously. Wind requires warmth. On Earth, sunlight heats oceans and continents, lifting air into the sky and pushing it across the surface. Storms roar, breezes whisper, the atmosphere dances. We accept this as universal. Cold worlds, frozen worlds, dead worlds should be still. Their air should hang motionless like a forgotten veil. Pluto refuses to accept that script. At 5 billion kilometers from the Sun, where daylight is a pale imitation of light, Pluto breathes. The air is thin, so thin that a human could not detect it without instruments, and yet it moves. Invisible tides of nitrogen and methane drift across its plains, tracing paths that no scientist expected to see. The winds are not storms, not howling gusts, but slow, deliberate currents that reshape the planet grain by grain. They speak softly, but they speak constantly. To understand them, you must first understand a process that should be impossible here: sublimation. On Pluto, nitrogen ice evaporates directly into gas without melting. The faint warmth of the distant sun strikes the surface, and even at temperatures that would freeze steel, it whispers to the nitrogen, "Rise." When Pluto rotates, the newly heated regions cool again. The gas condenses and falls, returning to the plains as frost. Day becomes night, night becomes century. This breathing cycle unfolds not in hours, but over decades. Scientists once assumed this cycle would be static, frozen in place like an antique machine rusted beyond motion. But new horizons revealed evidence of atmospheric circulation. Dunes, actual wind-formed dunes, curve across the edges of Sputnik Planitia. Their shape is unmistakable. Long, parallel ridges made of methane ice grains, aligned by the push of flowing air. You can imagine them forming one particle at a time, each speck nudged forward by a gust you would never feel against your skin. This is the heart of the paradox. Wind requires temperature contrast. Contrast requires energy. And Pluto, in theory, should not have enough energy to stir dust, much less sculpt landscapes. Yet it does. Why? The answer lies in the geometry of the nitrogen plains. Sputnik Planitia is a basin. Its colder surface acts like a trap, catching gases that condense into it. The warmer areas along the edges release vapor. The vapor moves, sinking and rising, forming currents that sweep around the basin in circular flows. Pluto's winds are not random. They are structured, guided, and channeled by invisible pressure gradients that wrap around its icy heart like a silk ribbon. Imagine a world where a single sunrise is weaker than twilight on Earth, and still the air shifts. Imagine dunes that form over centuries, shaped by breezes so thin that they would slip through your fingers unnoticed. This is Pluto's atmosphere, a whisper powerful enough to move mountains of frost. And here is the unsettling truth. A dead world cannot do this. It cannot sculpt dunes. It cannot circulate gases. It cannot maintain a system of seasonal winds that ebb and return. To have wind, Pluto must have a pulse. Something warms it, stirs it, and makes it breathe. And whatever that something is, it has been at work for billions of years, defying every rule we thought we understood. When images of Pluto's atmosphere first came back from New Horizons, they did not look like the sky of a frozen world. They looked engineered, not a vague halo, not an uneven blur, but precise, deliberate bands of blue haze stacked in concentric rings like the ribs of a cathedral. 30, 40, 50 layers, each distinct, each suspended at its own altitude, separated by gaps as clean as architectural flaws. They appeared too organized, too symmetrical, too intentional. Scientists stared at the photographs in disbelief. This was not the wispy exhalation of a dying planet. This was structure. The haze on Pluto forms when ultraviolet sunlight strikes methane molecules in the upper atmosphere. The energy fractures them, forging complex hydrocarbons, tholins that condense into tiny particles. On Earth, such aerosols scatter into turbulent clouds. On Titan, they descend as a uniform orange soup. On Mars, they drift as dust storms. But on Pluto, these particles do not behave like weather. They behave like geometry. The layers are spaced evenly, like lines on ancient parchment. They stretch across the entire horizon, wrapping Pluto's limb in a luminous shell of pale sapphire. Viewed from the spacecraft, those layers appeared to glow from within, like neon rings etched into blackness. There is something unnerving about a world so distant, so cold, exhibiting such order. Where does this order come from? One hypothesis suggests a wave-like phenomenon. As Pluto's atmosphere cools with altitude, subtle temperature inversions form zones where gases resist mixing. Tholin particles settle into those zones, trapped like dust in calm water. Each band becomes a stable shelf, building another atop it. Over decades, the sky stratifies into rings of suspended chemicals. It is a slow-motion sculpture carved by physics. Yet the data tells a stranger story. The layers are too clean. They persist even in regions where winds should disrupt them. They rise hundreds of kilometers above the surface, far beyond the altitude at which simple condensation can explain their formation. And they appear in patterns that suggest something deeper, something rhythmic. Imagine standing at the edge of Sputnik Planitia. The nitrogen glacier warms in sunlight. Vapor rises, carrying dust and hydrocarbon particles with it. At nightfall, the gases cool, fall, and freeze out. The next sunrise begins the process again. Every cycle injects more particles into the atmosphere, where they accumulate in stratified steps. For centuries, the planet repeats its breath, shaping the sky layer by layer. The result is a planetary memory, a record written in air. Some researchers quietly wondered if we were seeing the aftermath of old eruptions, geysers of methane jetting upward and settling into rings. Others posited shock waves traveling through the atmosphere from glacial flows below. Each explanation raised more questions than it answered. None have been proven. There is a peculiar irony here. Pluto's atmosphere is so thin that a seated adult could wave their hand and never feel it. Yet it holds structure more elegant than anything we see on Earth. If you looked up from Pluto's surface, you would not see a blank sky. You would see delicate blue lines stretching upward into infinity, like steps leading away from a world that refuses to be silent. It is hard not to wonder at that. Not because it suggests design, but because it suggests intention. A planet fighting to shape its own sky. Even at the edge of the sun's reach, when most people imagine Pluto, they picture a world so cold that even thought freezes. A ball of nitrogen frost drifting in eternal night. Brittle and unchanging, an ocean is the last thing anyone expects. Oceans are for places kissed by the sun, Earth, maybe Europa, maybe Enceladus if you're daring. Pluto should be bone dry, frozen to its core, incapable of holding liquid anything. That assumption held for decades. Then we got data. Not theories, not speculation, evidence. The first sign came not from pictures, but from gravity. As New Horizons flew past Pluto, it tracked subtle changes in the spacecraft's acceleration. These deviations revealed how mass is distributed beneath the surface. Something didn't add up. Sputnik Planitia, the vast nitrogen basin that forms one lobe of Pluto's heart, sat precisely where it shouldn't. A depression filled with lighter material should lower the planet's center of mass. Instead, it lifted it. It behaved like a weight, not a void. The most compelling explanation that fits the numbers is astonishing. There is something denser beneath the ice, a buried layer, a slab of liquid that refuses to freeze. Water, not vapor, not frost, not crystal. Salty, pressurized, liquid water locked beneath kilometers of nitrogen ice. How could that be? Pluto is too small, too distant, too ancient for internal warmth. The sun here is a pale white bead, barely brighter than a star. Pluto's core should have cooled billions of years ago, yet something is keeping it warm. Some process is preventing its oceans from turning to stone. One candidate is radioactive decay. Deep within Pluto's rocky interior, unstable elements may be quietly releasing heat slow, steady warmth sustained over eons. And though that heat would be weak by human standards, it only needs to fight one opponent: cold. Not evaporation, not sunlight, not tides, just the absence of warmth. Under layers of insulating nitrogen and methane ice, that tiny trickle becomes enough. Another clue lies in the shape of Sputnik Planitia itself. The basin appears to have migrated. It sits directly opposite Charon, as if Pluto rotated to reposition it. That kind of global reorientation requires a massive, fluid interior, a planet willing to twist itself for balance. A crust sliding around a liquid core. Dead worlds do not shift continents. Then there are the fractures, long, sweeping scars across Pluto's equator, stretching hundreds of kilometers. They resemble the stress marks of worlds with expanding interiors. If a deep ocean slowly freezes over time, ice expands, pushing outward. The crust splits. Europa has them, Enceladus has them, Pluto has them. The pattern is unmistakable. No one is claiming whales swim there or coral reefs glow in the dark. This isn't fantasy. It is physics. It is chemistry. The universe does not care what labels we give to planets. It only obeys its own rules. And one of those rules is simple. Liquid water appears wherever energy lingers long enough. The scientists aren't excited because Pluto might have an ocean. They're shaken because Pluto shouldn't have one at all. And yet, beneath the ice, something ancient still stirs a heartbeat we never expected to hear. There is a strange irony to Pluto's surface. The places most stained, most discolored, most alien are not dead at all. They are reminders of chemistry older than the Earth. They come from tholins, organic compounds forged not by biology, but by sunlight and cold vacuum, working together like an invisible alchemist. To understand tholins, you must first understand their birthplace. Pluto's atmosphere is thin, wispy, so faint that the pressure above its plains is less than a millionth of Earth's. Yet inside that thin veil, sunlight does something radical. Ultraviolet radiation too weak to warm your skin, but strong enough to split molecules, strikes methane gas floating above the surface. Each photon slices methane apart like scissors through ribbon, dislodging atoms and freeing carbon to bond with nitrogen and hydrogen. These shattered fragments recombine into complex hydrocarbons, first tiny chains, then longer molecules, eventually tangled webs of carbon-rich matter that drift downward like dust. These are not dyes, they are not surface stains, they are prebiotic organics, building blocks from which life on Earth once learned to assemble itself. Every world with methane in its skies seems to produce tholins. Saturn's moon Titan wears them like an orange cloak. Comets carry them in their icy hearts. But on Pluto, they appear in a way that feels personal. They settle unevenly, highlighting mountains, outlining plains, tracing the edges of glacial flows. In the polar regions, they deepen into dark, crimson-black stains, patches of chemistry, where radiation has reshaped carbon for millions of years. It's important to understand, tholins are not life. They do not reproduce, metabolize, or sustain themselves. They cannot breathe. They cannot grow. On early Earth, compounds like these accumulated in oceans and puddles of warm water. Lightning struck, heat churned. Eventually, chemistry became biology. Proteins formed. Membranes wrapped themselves around molecules. The transition from chaos to cell began with material not unlike the dust now coating Pluto. Imagine tholins as letters waiting for a writer. They are raw alphabets of carbon, nitrogen, and hydrogen symbols that life could arrange into sentences if given energy, solvents, and time. Scientists studying them do not ask, "Is there life?" They ask, "Is the universe preloading the ingredients everywhere it can?" The presence of tholins on Pluto hints that prebiotic chemistry is not rare. It is automatic. It arises wherever radiation meets methane. Not a miracle, but a mechanism. A rule so simple the cosmos repeats it again and again. Look at Pluto in that light, and the darkness of its plains becomes something other than a stain. It becomes a message, a record of countless epochs in which sunlight, weak as it may be, continued to sculpt the planet molecule by molecule. Pluto collects these molecules the way the early Earth collected amino acids, quietly, persistently, unceremoniously. It does not matter that it lacks oceans on the surface. It does not matter that sunlight is too feeble to do more. The chemistry is patient. Tholins are Pluto's memory of the universe's first experiments in complexity. They whisper a reminder that biology did not begin as biology. It began as dust and radiation, shaped by time. If life is ever found in the cold outer dark, it will not begin with breath or heartbeat. It will begin with pigments like these waiting for their next transformation. There is a strange irony to Pluto's surface. The places most stained, most discolored, most alien are not dead at all. They are reminders of chemistry older than the Earth. They come from tholins, organic compounds forged not by biology, but by sunlight and cold vacuum, working together like an invisible alchemist. To understand tholins, you must first understand their birthplace. Pluto's atmosphere is thin, wispy, so faint that the pressure above its plains is less than a millionth of Earth's. Yet inside that thin veil, sunlight does something radical. Ultraviolet radiation too weak to warm your skin, but strong enough to split molecules, strikes methane gas floating above the surface. Each photon slices methane apart like scissors through ribbon, dislodging atoms and freeing carbon to bond with nitrogen and hydrogen. These shattered fragments recombine into complex hydrocarbons, first tiny chains, then longer molecules, eventually tangled webs of carbon-rich matter that drift downward like dust. These are not dyes, they are not surface stains, They are prebiotic organics, building blocks from which life on Earth once learned to assemble itself. Every world with methane in its skies seems to produce tholins. Saturn's moon Titan wears them like an orange cloak. Comets carry them in their icy hearts. But on Pluto, they appear in a way that feels personal. They settle unevenly, highlighting mountains, outlining plains, tracing the edges of glacial flows. In the polar regions, they deepen into dark crimson-black stains, patches of chemistry, where radiation has reshaped carbon for millions of years. It's important to understand, tholins are not life. They do not reproduce, metabolize, or sustain themselves. They cannot breathe. They cannot grow. On early Earth, compounds like these accumulated in oceans and puddles of warm water. Lightning struck, heat churned. Eventually, chemistry became biology. Proteins formed. Membranes wrapped themselves around molecules. The transition from chaos to cell began with material not unlike the dust now coating Pluto. Imagine tholins as letters waiting for a writer. They are raw alphabets of carbon, nitrogen, and hydrogen symbols that life could arrange into sentences if given energy, solvents, and time. Scientists studying them do not ask, "Is there life?" They ask, "Is the universe preloading the ingredients everywhere it can?" The presence of tholins on Pluto hints that prebiotic chemistry is not rare. It is automatic. It arises wherever radiation meets methane. Not a miracle, but a mechanism. A rule so simple the cosmos repeats it again and again. Look at Pluto in that light, and the darkness of its plains becomes something other than a stain. It becomes a message, a record of countless epochs in which sunlight, weak as it may be, continued to sculpt the planet molecule by molecule. Pluto collects these molecules the way the early Earth collected amino acids, quietly, persistently, unceremoniously. It does not matter that it lacks oceans on the surface. It does not matter that sunlight is too feeble to do more. The chemistry is patient. Tholins are Pluto's memory of the universe's first experiments in complexity. They whisper a reminder that biology did not begin as biology. It began as dust and radiation, shaped by time. If life is ever found in the cold outer dark, it will not begin with breath or heartbeat. It will begin with pigments like these waiting for their next transformation. On Earth, seasons are familiar rhythms. You feel them in your bones. Spring's thaw, summer's heat, autumn's decay, winter's rest. They arrive and pass in predictable cycles, just long enough for us to grow comfortable and then forget. On Pluto, those rhythms stretch until they fracture human intuition. Seasons there do not belong to lifetimes. They belong to eras. Pluto takes 248 Earth years to orbit the Sun once. One Plutonian year lasts longer than the time between the Renaissance and today. Entire empires could rise, flourish, and vanish before Pluto completes a single circuit. Imagine standing on its surface. Your horizon is a frozen plain of nitrogen ice. The sun hangs in the sky, small, pale, a white star no brighter than a faint twilight. Its light is not something that warms you. It is something you notice the way a sailor notices a distant lighthouse. Calm, patient, always far away. Weeks pass, and still the shadows do not shift. You could live an entire human life on Pluto and never see the season you were born into end. This is not poetic exaggeration. It is geometry. Pluto's orbit is elongated, stretched like tensioned wire. When it is closest to the Sun, it basks in a weak but measurable warmth. When it is farthest, darkness deepens, temperatures plunge, and the atmosphere itself collapses into frost. The world exhales and then freezes its own breath. As Pluto moves toward perihelion, the near point its frozen gases awaken. Nitrogen, methane, and carbon monoxide sublimate from the ground, rising into the sky to form a thin but global atmosphere. Winds begin their slow migration. Frost lines retreat. Entire regions brighten not because ice melts, but because freshly exposed surfaces reflect more sunlight. A world that was silent for decades begins. Then the pendulum swings back. Pluto drifts farther away. The sunlight weakens until it is barely a whisper. The atmosphere condenses. The gases fall like invisible snow. The air itself collapses onto the plains, thickening layers of amber frost. The world becomes quieter, colder, heavier. The implications are unsettling. Hills form under frost that accumulates for decades, then vanish under glaciers that creep for centuries. A dune begins to move and will not finish its migration until your great-grandchildren's great-grandchildren are dust. The scars we call geological memory. On Earth, volcanoes, erosion, shifting continents occur here in slow motion. Pluto is not a static world. It is an extremely patient one. Human perception is too narrow to grasp such time. Even astronomers struggle. Our senses evolved to recognize patterns over hours, seasons, or years. We expect cause and effect. We expect action and reaction. Pluto breaks this reflex. Its changes are measured not by personal experience, but by archives and instruments, objects we pass down across generations to witness what our eyes never will. On Pluto, time is not a river, it is a glacier. For most of human history, Pluto was a blur, a smudge of dim reflected sunlight across a telescope plate. No spacecraft had ever come close enough to resolve its surface. It was a world defined by distance and assumption. Scientists expected it to resemble other small, cold bodies, heavily cratered, geologically inactive, ancient. Then, New Horizons arrived. The spacecraft had traveled for 9.5 years, coasting past Jupiter, slingshotting toward the edge of the solar system, its instruments dormant until the final approach. On the morning of July 14th, 2015, the first high-resolution images began to stream back to Earth. People in the mission center leaned closer to their screens, not because there was an error, but because the images were unexpectedly beautiful. Pluto was not sterile or uniform. It had texture, contrast, structure. In the center of the first color mosaics was a bright, heart-shaped region, later named Tombaugh Regio, honoring Clyde Tombaugh, the astronomer who discovered Pluto in 1930. One half of that heart, Sputnik Planitia, immediately revealed something extraordinary. Its surface was astonishingly young. Not young compared to human history, but geologically young. Craters, which accumulate on inactive surfaces over millions of years, were almost non-existent there. Something was resurfacing the plain, erasing impact scars faster than they could accumulate. Within days, higher resolution passes confirmed the implication. This was not a fossil world. The plains were composed of nitrogen ice, and the surface displayed large polygonal patterns, cells tens of kilometers across. These patterns were a physical fingerprint of convection. Warmer nitrogen rising from below, cooler nitrogen sinking at the edges. That meant energy was moving through the ice. Pluto, despite its size and distance from the Sun, had an internal heat source. Then, the mountains came into focus. Not built from nitrogen or methane, which would slump and collapse, but from water ice, acting as rock in Pluto's environment. This was not a landscape frozen into stillness. It was a terrain shaped by slow, persistent processes. Glacial flow, uplift, fracture. The surface had zones that were far younger than the solar system. Others were ancient, cratered and scarred. It was a mosaic of time, an active world beside a fossil one. New Horizons also passed behind Pluto, a maneuver called an occultation, and looked back toward the Sunday. The instrument data revealed layered atmospheric hazes, more than a dozen distinct strata rising hundreds of kilometers above the surface. Photochemical reactions in the upper atmosphere formed complex hydrocarbons that drifted downward, coating the plains with a reddish tint. Even the sky had structure. The mission team did not need to force a narrative. The data spoke clearly. Pluto was not an inert ice ball. It was a geologically and atmospherically dynamic dwarf planet. The moment New Horizons arrived did not close a chapter. It opened one, showing us that activity and complexity do not belong only to giants or to worlds warmed by the Sunday. They can thrive in darkness, quietly. For billions of years, before New Horizons arrived, the physics of Pluto seemed straightforward. A small world loses heat quickly. Its core cools, its crust freezes solid. Without tidal forces or solar warmth, geological activity ceases, and the planet becomes a time capsule, its surface a record of every impact since formation. That was the expectation. That was the model. What New Horizons revealed forced scientists to rewrite it. The first clue came from Sputnik Planitia, the vast basin of nitrogen ice that dominates Tombaugh Regio. Its surface is patterned with enormous polygonal shaped cells tens of kilometers wide. These are not random. They are diagnostic. On Earth, similar patterns form when hot material rises from below and cooler material sinks around the edges. It is convection, a process that requires heat moving through a medium. But Pluto is billions of kilometers from the Sunday. Its surface temperature is around 230 degrees Celsius. Nothing there should be warm enough to flow, yet the nitrogen does. Nitrogen ice, unlike water ice, becomes soft and mobile at extremely low temperatures. A few degrees of variation caused by internal heat or weak sunlight can push it into motion. Over hundreds of thousands of years, the ice rises and falls. Each cell in Sputnik Planitia is a conveyor belt of frozen atmosphere. Warm nitrogen rising at the center, cooling at the edges, sinking back down, resurfacing the plains. This mechanism erases craters, erases scars, erases time. It suggests not only motion but a heat engine beneath the surface. The source of that heat is debated. Some models point to radioactive isotopes embedded in Pluto's rocky core atoms, decaying slowly over billions of years, releasing energy grain by grain. Others invoke insulation. Pluto's crust is layered, nitrogen over methane over water ice. These materials trap internal warmth like blankets, reducing the rate at which energy escapes to space. If the world began with enough thermal energy, it may simply have never lost it. Then there are tectonic hints, fractures thousands of kilometers long stretching across the landscape. These are not random cracks. They show extensional stress pulling apart rather than compression. On Earth and Europa, such features often signal the expansion of an icy shell. If Pluto once held an internal ocean, and that ocean slowly froze, it would expand. Water expands as ice unique among common substances. A freezing ocean could literally push Pluto's crust outward, tearing the surface like an overinflated balloon. Even New Horizons gravity measurements recalibrated expectations. Sputnik Planitia's basin should be a gravity low-lighter material in a depression, but it is not. The region behaves as a gravity high. The simplest explanation is that water denser than nitrogen exists beneath the glacier, supporting and uplifting it. This hypothesis links surface behavior to deep interior structure, implying long-term geologic feedback on a world previously written off as inert. Small icy bodies were supposed to be fossils, static, predictable. Pluto instead exhibits phenomena once thought reserved for planets with global oceans or tidal heating. Convection, resurfacing, crustal migration. Its dynamism isn't a glitch in the model, it is evidence that our model was incomplete. Every polygon of Sputnik Planitia is like a clock gear, turning so slowly that no single human will ever see it move. Yet humanity has seen its effects. A surface renewed, a basin lifted, a world quietly remaking itself in the darkness. Pluto is not dead, it is patient. And patience, it turns out, is its engine. In geology, size is destiny. At least, that is what textbooks once claimed. Smaller worlds cool quickly, stagnate, and die. In this model, Pluto should have been a fossil. A frozen shard left over from the formation of the solar system, static, stable, unchanging. And yet, everything we have seen from it rejects this rule. Before New Horizons, the paradigm was built on the worlds we knew best: Earth, Mars, the Moon, Mercury. Big equals active. Small equals inactive. It was elegant, it was simple, but it was also narrow. These bodies orbit close to the Sun, blasted by radiation, bombarded by debris, and forged in a gravity well that shaped them with violence. Their stories were not universal. They were exceptions disguised as laws. Pluto forced us to look outward and realize how wrong we were. When geologists first examined its terrain, they didn't find the crater-scarred face of an ancient object. They found layers of time, regions resurfaced in the last few million years, mountains made of water ice swollen upward by deep internal forces, plains where nitrogen flowed like glaciers, erasing impacts as they formed. Each feature contradicted expectations. The entire planet seemed to possess a system of renewal. This was not supposed to be possible without tidal heating or a strong energy source. Jupiter's moon Io is alive because it is twisted by gravity. Its orbit kneaded like dough by the pull of a gas giant. Saturn's Enceladus erupts because its icy shell flexes around a warm core. These are worlds powered by giants. Pluto has no such master. No nearby planet forces it to knead or squeeze. Its companion, Charon, is gravitationally locked, balanced, not strained. According to every prior model, Pluto should be asleep. So where does the power come from? Some scientists point to radioactive decay, a whisper of warmth left in its rocky interior since the day it formed. Uranium, thorium, and potassium atoms quietly breaking apart, releasing energy atom by atom, not enough to melt mantle rock, but perhaps enough to drive slow movement under insulating layers of ice. Others see evidence of an internal ocean saltwater trapped beneath the crust, resisting total freeze. Water expands when it becomes ice. A freezing ocean forces the surface outward, cracking it along 1,000-kilometer faults. That expansion is written across Pluto in scars as clear as handwriting. And then there is the nitrogen cycle itself. On Pluto, atmosphere and surface trade materials, like lungs exchanging air. Nitrogen freezes, sublimates, returns, forming winds and glaciers. The planet is in dialogue with itself. Even without volcanism or tectonics, it has feedback loops closed, systems that respond to slight changes in temperature or sunlight. What Pluto truly dismantles is not a single idea, but a worldview. Small means simple. It breaks the assumption that complexity requires mass, heat, or proximity to the sunday. It suggests that planetary life cycles, geology, chemistry, atmosphere, may not be confined to the traditional categories we inherited from terrestrial examples. The solar system is not neat. It is not hierarchical. It is not ruled by size. Pluto is proof that even the smallest worlds can endure, adapt, reshape themselves, and carry secrets billions of years old, not as fossils, but as breathing organisms in slow motion. A planet may be quiet, but quiet does not mean dead. It may simply be evolving on a timescale too long for us to notice. When New Horizons revealed Pluto's surface to be active, textured, and young, the most unsettling implication did not concern geology at all. It concerned biology. Not in the Hollywood sense, not green creatures or frozen fossils, but in the slow chemistry of possibility. For decades, Pluto was dismissed as too small, too cold, too remote to matter. Uninhabitable was a given. Life was not a question. It was irrelevant. Only after we discovered that Pluto behaves like a living system did the question become legitimate. If life could exist anywhere here, where would it hide? Habitability begins with three ancient requirements, one that Earth met, and one that worlds like Europa and Enceladus now challenge. Liquid water, a source of energy, and chemistry capable of complexity. On the surface, Pluto fails at all three. Temperatures plunge to 230 degrees Celsius. Sunlight is too weak to heat a stone. Cosmic radiation scours exposed ice. The plains of nitrogen and methane look hostile to anything recognizable. If you only look at the skin of Pluto, you see a desert, but the skin is not the body. Deep beneath Sputnik Planitia, evidence points to something extraordinary, a subsurface ocean. Not a fantasy, not a theoretical puddle, but an internal water layer sustained over billions of years. No one expected this. On a world smaller than our moon, heat should vanish quickly, but it hasn't. The ocean is thought to be salty, like Earth's seas, and likely mixed with ammonia, nature's antifreeze. That combination can remain liquid far below freezing, cradled beneath kilometers of insulating ice. If life ever found a foothold here, it would not breathe air or photosynthesize. It would live in darkness, fed by chemistry alone. Consider the vents on Earth's ocean floor. The hydrothermal chimneys where sunlight never penetrates and volcanic heat nourishes entire ecosystems. Tube worms, archaea, bacteria, the first organisms on Earth, may have emerged from environments like these. The recipe is remarkably simple: energy gradients, minerals, and time. Pluto has at least two of those ingredients: energy from radioactive decay in the core, time measured not in centuries or millennia, but geological epochs, and chemistry that arrives from above. Tholins, forming in Pluto's upper atmosphere, rain down onto the surface. They are complex organics, prebiotic building blocks, a world constantly coated with the raw alphabet of carbon and nitrogen. On the surface, they freeze into pigment. But in an internal ocean exposed to salts or heat, those molecules become food, fuel, catalysts, seeds. If habitability exists on Pluto, it is not a bright oasis. It is a refuge in the dark, a biosphere sealed beneath pressure, insulated by nitrogen, shielded from cosmic rays by layers of ice rock. There would be no forests, no continents, no sky, only microbial colonies drifting in black water, metabolizing chemicals the way they do in the basins of Earth's deepest oceans. Scientists are cautious. No one claims that life is there. No one promises discoveries. But unlike a decade ago, the question is no longer dismissed. Pluto is not simply cold, it is structured. Not inert, it is dynamic. It has heat, chemistry, and shelter. And if life in the universe prefers places that endure quietly, slowly, unseen, Pluto may be one of the safest havens it has ever known. For most of planetary history, Pluto was seen as a stray, an interloper wobbling through the outskirts of the solar system, crossing Neptune's orbit like a vandal ignoring traffic laws. To astronomers in the 20th century, the oddity was something to be explained away or corrected. A mistake, a misclassification, perhaps even an accident. But as our maps of the outer solar system expanded, a different picture emerged. It maintains an elegant gravitational rhythm, with Neptune called a 3-to-2 resonance. That phrase may sound technical, but the meaning is simple. For every 3 orbits Pluto finishes, Neptune completes 2. Their gravitational pulls interlock like gears in a watch. Pluto never collides with Neptune, not by chance, but because the rhythm prevents it. From Earth, this looks like coincidence. In motion, it is choreography. We used to believe orbital resonance was something that belonged to the gas giants. Jupiter commanding hundreds of asteroids, Saturn keeping its moons in line. Pluto, so small and distant, shouldn't have the mass to influence anything. But the Kuiper Belt is not empty. It is a region of worlds, planets, dwarf planets, fragments each carved from the early solar system. And many of them are caught in Pluto's rhythm. The 3-to-2 resonance zone is crowded with objects called Plutinos worlds, trapped in the same gravitational beat as Pluto. Some are smaller than mountains. Others rival Pluto in size. They orbit the Sun in the same cadence, as though Pluto is a conductor tapping the tempo. They don't orbit Pluto itself. Pluto simply occupies the center of a gravitational pattern that shepherds them. It's as though the solar system has sheet music, and Pluto is the note that tells the orchestra when to breathe. This is why categorizing Pluto as an oddity misses the point. It is not isolated, it is influential. To understand how strange that is, consider this. Pluto is not massive enough to clear its neighborhood, a requirement the IAU used to disqualify it as a planet. Yet it does exert long-term orbital authority. It does shape the Kuiper Belt. It does keep dozens of bodies in stable motion. The irony is painful. Pluto was demoted for failing a criterion that doesn't account for the kind of influence it actually has. Resonance is not brute force, it is balance. A soft gravitational handshake repeated for billions of years. Think about what resonance implies. If one world speaks, others listen. A tiny dwarf planet holding the rhythm of entire populations of icy worlds, like a lighthouse that flashes so predictably that passing ships align their course to it. This isn't fantasy. It is orbital mechanics. Resonance is one of the universe's most elegant structures, and Pluto sits at one of its most crowded intersections. And here lies the quiet revelation. Resonance traps do not end with the worlds we know. There are bodies in the Kuiper Belt that have never been catalogued, moving invisibly through darkness, unseen by our telescopes. They drift across orbits shaped by Pluto's cadence, following a path older than humanity. Older even than Earth's continents. Dozens more wait to be discovered, some the size of cities, others rivaling Pluto itself. Pluto isn't a leftover. It is a guidepost, a gravitational lighthouse at the edge of the solar system, marking paths for worlds we haven't even named yet. For most of the 20th century, the solar system was imagined like a neatly arranged museum exhibit. 8 planets, each orbiting in polite concentric rings, followed by emptiness. The textbooks portrayed it as an elegant climax. Everything interesting was close to the Sun. Everything chaotic had been tidied away. Pluto was a minor curiosity, an eccentric snowball at the brink of nothingness. It was a boundary, not a beginning. Then astronomers widened their gaze. In the late 20th century, with CCD sensors replacing photographic plates and telescopes turning digital eyes toward the darkness, the emptiness beyond Neptune began to crumble. One object was found, then another, then dozens. They were small, icy, faint, every one of them silently orbiting where nothing important was supposed to exist. This collection became known as the Kuiper Belt, and it did not behave like a junkyard. It behaved like a colony. The revelation was not that Pluto was strange. It was that Pluto was normal, and we were blind. The Kuiper Belt is not a scattering of debris. It is a population of worlds, objects hundreds of kilometers across, some with moons, some in binary pairs, some spinning in chaotic rotations like Pluto's smaller companions. A family of planets frozen at the edge of sunlight. And as more were catalogued, Haumea, Makemake, Quaoar, Orcus, Sedna, Eris, Pluto's uniqueness evaporated. It was no longer the single eccentric dot in a clean diagram. It was the first ambassador of a nation we had never visited. The solar system wasn't 8 planets and a mistake. It was 8 planets and a frontier. That frontier forced a reckoning. Planetary science isn't just about rocks and orbits, it is about models. A model is a story that scientists tell themselves when the data is incomplete. For centuries, the solar system model said, planets form near the sun, debris gets swept away, and the outer regions are quiet. It allowed children to memorize the universe like a list. The Kuiper Belt shattered that comfort. Suddenly, Pluto's demotion was not about a single world. It was about admitting the model was wrong. Because if Pluto remained a planet, then so must dozens of other bodies, each with the same right to the title. The solar system would no longer be a tidy sequence but an ecosystem, a sprawling archipelago, a chain of frozen continents orbiting together in slow, silent procession. The astronomical community attempted to constrain this chaos by redefining the term planet. It wasn't just a scientific refinement, it also worked as a kind of damage control, keeping the old picture from shattering completely. A decision crafted to preserve the illusion of order. The criterion, clearing the neighborhood, does measure something real about how dominant a world is in its orbit, but it also, perhaps conveniently, excludes Pluto and most of its kin in the Kuiper Belt. But models do not stay small forever. Data grows. Telescopes sharpen. Spacecraft arrive. The Kuiper Belt continues to expand in our understanding. It may contain hundreds of thousands of worlds, perhaps millions, bodies untouched since the birth of the solar system, fragments of cosmic history frozen before Earth even cooled. Each of them whispers the same truth. The solar system we teach in classrooms is not the solar system that exists. We didn't discover chaos at the edge. We discovered structure complexity and that the universe does not care about our diagrams. The Kuiper Belt is not an afterthought. It is Act 2 of the solar system, and we are only now learning to read it. Pluto is not a singular accident. It is not an anomaly at the fringe of the solar system. It is a member of a hidden lineage world sculpted not by rock and fire, but by nitrogen, methane, and water ice, acting under physics we are only beginning to understand. To see Pluto clearly, you must look at its family. And the most revealing member of that family doesn't orbit in the Kuiper Belt anymore. It orbits Neptune. That world is Triton. When Voyager 2 passed Neptune's largest moon in 1989, scientists were stunned in a way eerily similar to the reaction New Horizons triggered decades later. Triton did not look like a dead moon. It looked like a world in motion. Geysers blasted dark material into the atmosphere. Smooth plains stretched over old craters. Volcanic features, cryovolcanic ones, sprayed liquid nitrogen instead of molten rock. Triton was alive in a way no one expected. Its orbit was the first clue. Triton moves retrograde, opposite Neptune's rotation. No moon forms like that. It must have been captured, pulled from elsewhere. And where could it have come from? From the Kuiper Belt, from Pluto's neighborhood. Triton is a fossil of the outer solar system's migration, a captured cousin torn from its original path. Its internal heat, not powered by sunlight, must come from within. Tidal stress from its irregular orbit, radioactive decay, or both. That heat drives an atmosphere thick enough to weather the surface, to fuel nitrogen geysers that erupt like inverted fountains. And that atmosphere doesn't care about its size. Nowhere in its physics is there a rule that says only large worlds can breathe. Scientists learned from Triton that chemistry becomes dynamic long before size becomes relevant. a small body with volatile ices and slow, forgiving temperatures, can become a chemical factory. Methane becomes tholins. Nitrogen becomes dunes and frost cycles. Landscapes rewrite themselves. Pluto is not the exception, it is the inheritor. Look at another example. Eris, the world whose discovery triggered Pluto's demotion. Far colder than Pluto, its surface likely cycles frozen nitrogen and methane. Make, with methane ices vaporizing into thin atmospheres. Haumea, elongated and fractured, orbited by icy shards that speak of catastrophic formation. Each world operates on rules that do not mirror Earth, Mars, or Venus. They belong to a class that is not terrestrial or Jovian, but something else entirely. Worlds governed by exotic ices interacting over geological epochs. Nitrogen worlds share a quiet logic. They do not need heat from the Sunday. They store energy not in molten cores or violent atmospheres, but in frozen layers that move a millimeter at a time. Their landscapes change not over decades, but over millions of years. They are planets of patience. Pluto's nitrogen glaciers and Triton's nitrogen geysers are separated by billions of kilometers, but they speak the same language. Both worlds insist that the solar system has a second paradigm, one where alive does not mean lush or warm, but active, persistent, and evolving. We once believed that Earth-like planets told the whole story. The nitrogen worlds quietly disagree. They suggest that life, or at least the machinery that precedes it, thrives in places we never thought to look, not in sunlight, but in shadow. Science likes to pretend it is immune to emotion. Equations are neutral, measurements are impartial. The universe is what it is, regardless of whether we approve. But scientists are still human, and humans are deeply uncomfortable with uncertainty. When something refuses to fit, we don't celebrate it, we resist it. Pluto is not just a scientific controversy, it is a psychological mirror. For centuries, our model of the solar system was a story. The Sun at the center, 8 planets arranged like nested rings, comets drifting outside like crumbs from a celestial meal. It was simple enough for a child to understand. When Pluto appeared in 1930, we didn't question the story, we simply squeezed Pluto into it. A 9th planet, we told ourselves, and the story remained intact. But when the Kuiper Belt came into view, when other Pluto-sized worlds appeared, when Pluto itself showed mountains of water ice and nitrogen glaciers, the story began to collapse. And collapse is frightening, because a collapsed story doesn't only break a model, it breaks identity. Scientists who built their careers on a neat solar system were suddenly being asked to face a cosmos that refused to be neat. Their discomfort was not born of ignorance. It was born of loss. Children memorize planets. Adults build careers on them. Institutions publish papers about them. Entire education systems revolve around fixed answers. To admit Pluto is not anomalous, just the first of many means relearning the solar system from scratch. Not 8 planets plus leftovers, but a sprawling archipelago of worlds. Dwarf planets, binary systems, nitrogen moons, ice volcanism, internal oceans, a new solar system with no central hierarchy, no single dominant narrative. That is not a correction. That is a revolution. Humans instinctively reject revolutions that rewrite the past. When confronted with a truth that destabilizes our assumptions, we reach for the emotional defense that saved our ancestors. Simplify, categorize, reduce. This is why Pluto was demoted, not because the data demanded it, but because the data made us uncomfortable. The phrase has not cleared its orbit entered the textbooks not as a revelation, but as a refuge. It allowed the old story to survive with minimal damage. Neptune could remain what Neptune had always been, Jupiter could be king, Earth could be exceptional, and Pluto could be exiled, rebranded, turned into a symbol of disorder rather than a signpost pointing to the truth. People often talk about the IAU vote of 2006 as if it were a pure scientific epiphany. In many ways, though, it also acted like a coping mechanism, a way to preserve familiar mental architecture rather than fully embrace a more complicated universe. We fear ambiguity because it forces us to admit we do not know as much as we thought. Worse, it forces us to admit that the universe is under no obligation to remain simple. Pluto is difficult not because it breaks rules, but because it shows us that the rules were never real. They were conveniences, comfort blankets, wrapped around cosmic chaos. To understand Pluto is to surrender to uncertainty. And for many, that surrender feels like losing control. To understand Pluto, you cannot stop at the Kuiper Belt. That region is only the calm surface of a deeper disturbance, an echo of an ancient event that reshaped the architecture of the solar system. Beyond the neat ring of frozen objects, there lies a more chaotic domain, the scattered disk. It is a territory of exiles, where worlds travel on elongated orbits that stretch so far from the sun that centuries can pass without sunlight ever touching them. This region is not an accident. It is the aftermath of planetary violence. Billions of years ago, the giants did not sit quietly in the positions we find them today. Jupiter, Saturn, Uranus, and Neptune were restless migrants, shifting outward and inward as they interacted with the debris left over from formation. In one of the leading narratives, a phenomenon called the Nice model, Neptune and Uranus moved outward through a dense population of icy bodies. Their gravity was not gentle, it was disruptive. Every world they passed, they pulled, dragged, or hurled into new orbits. Some were slingshotted inward toward the sun. Others were ejected into interstellar space. Many were pushed outward into long, looping trajectories that would never stabilize. Those survivors became the scattered disk. Unlike the Kuiper Belt, which contains objects in relatively stable resonances like Pluto's, the scattered disk is a population of worlds on paths that look almost feral. Their orbits can tilt high above the plane of the solar system or dive deep beneath it. They stretch across tens or even hundreds of astronomical units. They are not tame. They are not periodic. They are reminders of the solar system's violent youth. A scattered disk object does not drift gently. It is tugged. Every close approach to Neptune warps its trajectory like a hand jerking a thread. Over millions of years, the orbit stretches, elongates, becomes a cometary arc, frozen in time. Imagine a pendulum, but with one end of its swing billions of kilometers away. Some of these worlds, such as Eris, are nearly the size of Pluto. Others, like 2000 CR 105 or Sedna, orbit so far and so slowly that they seem barely part of the solar system at all. Their existence suggests something even stranger, that Neptune alone may not have sculpted them. A hidden perturber, a massive unseen planet, or an ancient passing star might have pulled them into their current paths. To astronomers, the scattered disk is not an oddity. We tend to teach space as if planets formed in place and simply spun peacefully for billions of years. It is a ledger of every collision, every gravitational betrayal, every violent reshuffling of mass during the solar system's adolescence. The scattered worlds are not mistakes. They are fossils. In that light, Pluto's orbit tilted, resonant. Irregular is not an error in the formula. It is a clue. It hints at a solar system shaped by migrations and exiles, by interactions so powerful they can fling worlds into the dark forever. Pluto is not merely at the edge. It stands at the boundary between order and chaos, a signpost marking the scars of everything the giants once destroyed. If Pluto is the gateway to the Kuiper Belt, and the scattered disk is the debris field of cosmic migration, then Sedna is something else entirely. Sedna does not orbit like a Kuiper Belt object. It does not move like the scattered world exiles of Neptune's gravity. It is not in resonance, not controlled by Neptune's reach, not captured by Jupiter's chaos. Sedna is a whisper from the deep, a signal, not an answer. Its orbit is vast. Its closest approach to the Sun is farther than Pluto ever ventures, and its farthest point stretches to a realm that may as well be interstellar space. Sedna completes one orbit every 11,000 years. That means when the last ice age ended on Earth, Sedna was still on the same trip around the Sun, still tracing its immense arc through the darkness. Its trajectory is so extreme that no normal solar system process can explain it. Neptune cannot. The Kuiper Belt cannot. Random scattering events cannot. Sedna is the kind of orbit you get when the solar system has been touched by something large, something powerful, something we have not seen. Some astronomers call that something Planet 9. Not a brown dwarf or a rogue star, not science fiction. A planet, perhaps 5-10 times the mass of Earth, orbiting so far from the Sun that its light would be invisible from our telescopes, too distant to reflect brightness, too cold to radiate much heat. It would pull gently over millions of years, tugging ice worlds into elongated loops and keeping them aligned like iron filings bowing to a magnet. Sedna is not alone. Other objects follow similar, odd paths. 2012 VP, 113, 2004 VN, 112, 2013, SY, 99. Their perihelia, their closest approaches to the Sun cluster in the same region. Their orbital axes tilt together, angled as if responding to a hidden shepherd. This pattern is not random. If orbits were generated by chaos, the distribution would smear across space. Instead, they point. This does not prove Planet 9 exists. It proves something must. We are cautious because astronomy has known the pain of premature certainty. We once believed Neptune existed because Uranus behaved strangely, and we were right. We once believed Vulcan orbited inside Mercury, and we were wrong. Sedna sits between those two histories, daring us to look carefully. Some researchers argue that a passing star may have tugged Sedna in the early solar system. When the Sun was still forming inside its birth cluster, it may have brushed against another newborn star, their gravity fields intertwining for a moment. That encounter could have nudged a handful of worlds outward, exiling them into orbits like Sedna's. If so, the solar system carries scars of its cradle, an ancient memory encoded in celestial motion. Others suggest Planet 9, not a secret conspiracy, not a hidden Earth, but simply another planet in a system that has never been as tidy as we pretend. Sedna is quiet. It does not glow. It does not scream. It does not demand attention. It is a messenger. Its long arc tells us, you are not finished mapping this place. The solar system is not complete. It is not solved. It is not symmetrical. And Sedna drifts at the edge of everything we know, waiting patiently for the day our telescopes finally find the colossus that shaped its path. For nearly a century, Pluto has existed in the shadow of our definitions. First, it was a planet, then a mistake, then a dwarf planet, an attempt to demote it without fully exiling it. But every new piece of evidence we've uncovered tells us that Pluto is not an awkward outlier between categories. It is its own category, a kind of world we do not yet have language for. Think of what a planet is supposed to be: a single body with moons, a gravitational monarch ruling its surroundings. The gas giants are empires, the rocky planets are cities. Pluto is not an empire. Pluto is not even a city. It is a system, a miniature solar system, complete with feedback loops, atmospheric cycles, internal oceans, and an equal mass companion. A binary at its core, orbited by chaotic moons, sculpted by an energy source so stubborn it refuses to die. Charon is the key to this revelation. It is not a passive moon. It is a co-governor. Their barycenter, where gravity balances, is not buried deep inside Pluto, as with Earth and the Moon. It floats in open space as if two worlds are holding hands. No planet in our traditional sense behaves this way. Pluto and Charon rotate together, always facing each other, their tides locked in eternal conversation. Everything else, Styx, Nix, Kerberos, Hydra, circles that duet like debris around a double star. This is not a planet with moons. It is a planetary system in miniature. And then we look inward. Under Pluto's crust lies the possibility of an ocean, an internal sea insulated by nitrogen and methane ice. That ocean is not static. It may expand, contract, fracture its shell, drive the mighty scars that cut across the equator. Above it, nitrogen glaciers flow like rivers of frozen breath. They move, overturn, resurface. They erase ancient wounds and carve new ones. Nothing about this world is inert. Above the glaciers, a thin atmosphere forms and collapses with the seasons, an atmosphere that rises when Pluto draws closer to the sun and falls back to the surface when it retreats. The sky arranges itself into layered hazes that drift for hundreds of kilometers. Photochemical rings suspended in a structure more sophisticated than we ever expected. Most planets struggle to create stability. Pluto creates elegance. Everything about Pluto breaks our categories because our categories were never built to accommodate worlds like this. We imagine small things must be simple. Quiet things must be dead. Distant things must be unimportant. Pluto answers them all with a soft, unhurried contradiction. We call it a dwarf planet because we do not yet know what else to call it. Dwarf implies incomplete, lesser, unfinished. It means almost a planet, not quite enough. But Pluto is not enough. It is too much, too complex, too dynamic, too stubborn to fit in a box written for the 8 planets near the Sunday. It is the first example of a class of worlds that might outnumber the planets we learn in school. Binary ice worlds with internal seas, atmospheric cycles, and moons born from ancient collisions. Pluto is not the smallest planet. It is the first of something new, not a mistake, not a consolation prize. A prototype waiting for the language we will invent to describe it. Pluto began as a dot, a speck at the edge of a chart, the 9th bead on a string of planets we memorized in childhood. We were told it was insignificant, that it was too small, too cold, too far away to matter. But when we finally reached it, we discovered what the universe has whispered since the beginning. Smallness is a perspective, not a truth. You've now walked through the heart of Pluto, where frozen nitrogen flows like oceans. You've stood beneath mountains made of water ice, harder than granite. You've watched winds trace dunes across plains of frozen air. You've seen atmospheric hazes layered like rings inside a cathedral. You've sensed the steady heat beneath the shell, the possible oceans sealed away in darkness. You've witnessed a binary world, 2 bodies orbiting each other as equals, their smaller moons spinning in chaotic tribute. And beyond Pluto, you've glimpsed the architecture of a solar system we never understood, the Kuiper Belt, the scattered disk, the exiles from ancient migrations, and the lonely wanderers like Sedna that hint at unseen colossi. Every discovery pulls us further from the neat classroom diagrams we once believed in. Every revelation reminds us that the universe does not exist to be simple. We often seek comfort in boundaries and labels, but Pluto teaches us that reality doesn't ask for permission. Worlds can be active in the cold, life's ingredients can form where no sunlight reaches, and a system can thrive even when it doesn't resemble anything familiar. As you drift into rest, let this thought settle gently. We live in a universe that is larger, stranger, and more beautiful than any model we invent. And somewhere, far beyond the warmth of our sun, Pluto keeps moving slowly, deliberately carrying its secrets through the dark. Sleep well, traveler. The cosmos will still be here when you wake.